All right, you guys, today we're starting a new unit, Unit 10 on circles. If you notice on your calendar, this is a longer unit, so you want to make sure you're staying up to date on each piece as we go through. Also notice on Friday, you have a quiz over what we're doing today and tomorrow. Quiz on Friday. Okay, so today we're going to do a few things. We're going to introduce circles, talk about some vocab here. Then we're going to talk about arc length. And then we're going to talk about radians. Okay, so let's get started with just some basic vocab. An arc is going to be 2 points on a circle and all the included points. I would draw a picture out to the side of an arc. Probably no surprise there what that looks like. A minor arc, just like it sounds, is going to be a small arc. It's going to be an arc that is less than 180. It's going to be less than 180. So 180 is going to be referred to as a semicircle. So any arc that's less than that is going to be a minor arc. A major arc is just like it sounds. It's going to be a big arc. This is going to be an arc that is greater than 180 degrees. Then we're going to talk about sectors and arc length. A sector is going to be like a piece of pizza versus the arc length is just going to be the length of an arc. I like to call it the crust of the pizza. So sector is going to be a piece of a circle. What we're going to be doing is we're going to be finding the area of sectors tomorrow. So that'll be the area of that shaded piece of the circle. Arc length is going to be a piece of the circumference. And I think of it like the crust of the pizza. How long, if you were going to take a ruler or a measuring tape, how long is the piece of crust? That's the arc length. Okay. So just to get started with some basic circle information, we are able to find the measure of arcs just based on the angles in the center. So these angles in the center here are called central angles. And I know the measure, the degrees of arc AB. Just because the central angle is 90, that means that the degrees of AB is going to be 90. Now, does that mean that the length of the arc is 90? No. Length of the arc is going to be different than the measure. Whenever you see the word measure, you want to think degrees. So what's the degrees of AB? It's going to be 90 degrees. And the reason is because it's the same as the central angle. So BD would be 130 degrees because that's the measure of the central angle. To go on and find like the measure of AE, this piece, what I would do is first find a semicircle. In order to find a semicircle, you want to find a diameter. Remember, a diameter goes all the way across a circle, makes a straight line through the center. So diameter would be EB. Because that's a diameter, that tells me that this is a semicircle, and the degrees would be 180. So to get AE right here, what I would do is take 180 and subtract 90, which comes out to 90 degrees. So this one's 90. The same thing would go for trying to find ED, the measure of ED. Locate that semicircle. Notice this piece is 130, so subtract 180 minus 130 to get 50 degrees right here. From here, it's pretty simple to figure out the degrees of each one of the arcs that you see just based on adding the different pieces up. For instance, AE is 90 degrees. ED we found was 50 degrees. But if I wanted DE, BA, I would add. Start at D, go to B, that's going to be 130, and then to A, plus 90. 130 plus 90 comes out to 210 degrees. Don't forget your degree signs. For A, B, D, you would start at A, go to B, which is 90, then go to D, 130. So it'd be the same thing, 90 plus 130. Still a 210 degree arc. AED, from A to E to D, is 90 plus 50, which comes out to 140. And BD we know is 130. If you wanted to double check your work, you could add all the way around the circle and it should equal 360. When you're naming arcs, minor arcs are always named with 2 letters. So when you look above, all the 2-letter arcs are going to be minor arcs. Whenever you see 2 letters, you know that it's going to be the short direction around the circle. So if it asks for AE, that means it's a minor arc, so I'm going left. I wouldn't find arc AE by going right because that's a major arc and that would need 3 letters. So all minor arcs are 2 letters, so we just want to name some of the minor arcs in the picture above. One would be AE. Notice the notation needs an arc above it. Another minor arc would be AB. Maybe ED, DB. You could even say AD. And then you could flip all those letters around. DA, BD, DE, BA. All of those are different minor arcs names. Major arcs are always named with 3 letters. And remember, they have to be greater than 180. So another one, or a major arc might be ABD. Another one might be AED. Of course, you could flip all those around again. Another major arc might be EBA, so on and so forth. Then your semicircles are always going to be 3 letters, and they're going to add to equal 180. So EAB would be a semicircle, or EDB. Let's talk about circumference. Circumference should be a review for you guys. You should have this formula memorized, so put a big star by him. Circumference is 2 pi r. 2 pi r. And what we're going to do is keep our answers in terms of pi like we did in our last unit. So for number 1, to find the circumference, it would be 2 pi times 7. Remember, terms of pi just means to take the 2 times the 7 to get 14 pi. And you need your units. Units here are centimeters. Circumference is different than area. Circumference is similar to perimeter of a circle, so you don't want to use units squared. It's just regular units. To find circumference here, you could also use the circumference formula of pi d. The reason those are the same formula is because 2 times the radius is the same thing as the diameter. So for number 2, the circumference is just going to be the diameter, 20 pi. Don't forget your units. If we wanted to find the arc length of a circle, remember that's the measure, the length, if you were taking a ruler to the crust, how much crust is on your pizza, that's your arc length. It's just going to be a fraction of the total circumference of the circle. What I want you guys to make sure you connect is that whenever we're talking about arc length, you need circumference. Tomorrow we're going to be talking about area of a sector, and that's when you need area. Arc length needs circumference. So when you look at the next section, we're going to find arc length. We're going to be using this formula right here, and it's a proportion. The piece of the crust over the total crust, or circumference, is going to equal the piece of degrees over 360, the total degrees. What I want you guys to see here in this proportion is that it's piece over whole equals piece over whole. One of the fractions is going to be just based on the circumference and the arc length. Remember, they're related. And then the other fraction is going to be just on the degrees. The piece of the degrees over the whole degrees. And you guys know the whole degrees of a circle is 360. Piece over whole equals piece over whole. So what do we mean by that? Let's take a look at number 1. Find the arc length of AB. Notice it's asking for arc length, so I want to think of circumference, a piece of the circumference. So we're looking for arc length, and that goes over the whole circumference, 2 pi r. Here the radius is 2, so it's 2 pi 2, and that equals the degrees, 88, over the whole degrees, 360. We solve proportions by cross multiplying. The first thing I'm going to do is turn this 2 pi 2 into 4 pi. That'll be easier to deal with. Remember, we cross multiply. So you're going to get 360x. Then we want to multiply the 88 times the 40 pi. Now, or excuse me, 4 pi. Now what I'm going to do is I'm just going to go ahead and not keep it in exact form, but you can keep it in exact form. I'm going to take 88 and times it by 4 pi. That comes out to 1,105.84, but remember you're keeping it long in your calculator. Then to get x by himself, we're going to divide by 360 on both sides. X comes out to 3.07. Notice our units are in meters. Let's take a look at number 2. I want you guys to try this one on your own. You've got the degrees of 45. You've got the radius of 2. Go ahead and pause the video and see if you can work this one out on your own. All right, you guys, let's see if you got it right. Remember, arc length is what we're looking for, so that's the x over the circumference, 2 pi 12, equals degrees, 45, over 360. The piece of the crust over the whole crust equals the piece of degrees over the whole degrees. Cross multiply. 360x equals, this turns into 24 pi. So 45 times 24 pi comes out to 3,392.9. Divide by 360. Divide by 360. X should come out to 9.42, and that's in centimeters. Hopefully you guys got that one right. The next 2 problems are going to be working backwards. Let's take a look at number 3. Find the indicated measure. Here it's asking for circumference of the circle. Notice it's giving you your arc length, and the 290 is the degrees. That exclamation point is not supposed to be there. So arc length goes on top of my fraction, 46.75, over circumference, what we're looking for, equals degrees 290 over 360. Cross multiply, 290x equals 360 times 46.75, 16,830. Then divide by 290. X comes out to 58.03 feet. Also working backwards, we've got this next one here that's giving us our arc length and our degrees, and we have to work back to radius. So think about how we would do that. What we just did is we solved for circumference. But if I was given the circumference, could I solve for the radius? Yeah. Once we get here, what we're going to do is set that equal to 2 pi r and then get r by himself. So this guy gives us the arc length. Remember, that goes on top of your fraction because it's a piece of the circumference over the circumference, 2 pi r equals degrees 55 over the total degrees, 360. Now, I don't want you guys to get confused by putting too many letters in there. So what I'm going to do is I'm just going to call that C. Once we find him, we'll set it equal to 2 pi r. So cross multiply, you get 55C equals 19.71 times 360, 7,095.6, then divide by 55. So you get 129.01. That equals your circumference. So I'm going to say 2 pi r equals 129.01. And what we need to do is divide by 2 pi because we want the r to be by himself. Now, pay attention here, guys. When you're dividing by 2 pi, that's multiplication in your denominator. So you have to put it in parentheses. Otherwise, you'll always get this one wrong. So take it in your calculator and hit divide, parentheses, 2 pi. Can you see that? I have it long in my calculator and I'm dividing by all of the 2 pi. So my radius should come out to 20.5, and we're in centimeters. Okay. The last thing we're going to talk about today is radian measure. So I want to talk to you guys about circles real quick. Circles can have angles inside of them, like we've been talking about. And this angle measure right there can be measured in degrees or radians. Kind of like the length of something can be measured in inches or centimeters. They're just different units. So what we're going to do is we're going to talk about radians. The radian is the measure of a central angle like I have on the picture that intercepts, oh no, I'm going to run out of room, intercepts an arc with the length equal to the radius. Of the circle. So what that means is that the central angle here is the measure. The arc is the same as the radius. So this arc right here, length, would be the same as this radius. That's how you know when you have a radian. And we're going to talk about the different measures that radians can come in. Intercepted arc, all that means is that you are touching the circle, okay? The fancy definition is an arc of a circle with two endpoints on the circle. So, use a circle with a radius of 5 and an arc length of 10 pi. So I've got a circle and I've got a radius of 5. The arc length, remember we found arc length is the length of this arc, is 10 pi. What is the measure of the central angle, that theta means right here, the central angle, in radians? So instead of putting it in degrees, I want to put it in radians. So same thing as inches and centimeters, it's just a different measure. What you want to do is to find that central angle, you want to take the arc length, 10 pi, and put it over the radius, 5. 10 pi over 5. And that's going to be the measure of the central angle. You just want to make sure you reduce it. 2 pi. And instead of writing degrees, we're writing radians. Let's take a look at some more. Number 1, find the measure of the central angle in radians. So what we know is that that angle equals the arc length over the radius. So I'm looking for the central angle. So theta equals the arc length, 11, over the radius, 8. And then simplify. Can you simplify that? So you're just going to leave it. 11 over 8 radians. Same thing for number 2, arc length over the radius. So theta is going to equal the 6 pi over the 12. You want to reduce that to 1 pi over 2 radians. We're going to skip number 3 and go to the back. The last thing we're going to do is look at working a little bit backwards. This time you're given the radian measure and you're asked to find the arc length. So here's the arc length, here's the measurement of the angle, and here's the radius. So what we know is that if the theta equals arc length over radius, then radius times theta equals the arc length. I'm going to set it up like this though, just so we stay consistent with that same formula. The 2 pi over 3 equals theta equals the arc length m over the 19. You could solve this one of two ways. You can cross multiply and divide, or you can multiply this whole side by 19 and multiply this whole side by 19. But because we've been cross multiplying, I'm going to go ahead and do that. 3m equals 19 times 2, I should know that in my head, 38 pi. From there, you just want to get that m by himself, so you divide by 3. 38 over 3 doesn't reduce, so you can just leave it. 38 pi over 3. And that's in centimeters. Example number 2, we're still looking for that arc length. Actually, you know what? I want to change this one. Instead of looking for this arc length, I want to look for this one, W, over here. Okay? So what we're going to do is we're going to take that middle measure, 5 pi over 6, equals the arc length, what we're looking for, W, over the radius, 4. I'm going to cross multiply again. 6W equals 20 pi, then divide by 6. So W equals, you can reduce that to 10 over 3, 10 pi over 3 centimeters. Go ahead and do the next one on your own. Pause the video. All right, you guys, let's see if you got it right. That pi over 3 equals the arc length over the radius. Cross multiply, so you get 3c equals 2 pi, and then divide by 3. Did you guys get 2 pi over 3 feet? Hopefully so. All right, you guys, that is it for our notes today. You do have a practice that you're going to work on in class. Okay, so please follow those instructions. That will be graded. Make sure you're showing your work for full credit. And once you're done with that, turn it into the tray and pick up your homework. Okay, I will be back on Thursday to see you guys. If you have any questions, please feel free to come into tutoring.